Good morning, everybody. So today is Wednesday. So today we will finish 9.3 and 9.4. Because we are behind schedule, so I told you we try to cover one example of each type, but there are like some examples in the worksheets we might not be able to cover all of them. So yes, we're catching up. So I hope you can like pay attention in class and like do more exercise after class. If you have questions, ask me. So we might not have time for you to like practice in class. Okay, so this Friday we have the homework 9.2 and the quiz 4 due. And then next week you have 2 homework assignments and 2 quizzes. And then you can see the following month we're gonna be very busy because we cover 4 chapters, but we spend 10 weeks on 2 chapters. Now we only have like 6 weeks for. Okay, so we spend too much time on the first 2 chapters. Yes, okay, but thankfully we have a good foundation. You guys did better in like your scores improve in chapter 8. So yeah, hopefully it will be fine. But just keep in mind you're gonna be very busy. And I also want to remind you that we have the 12 homework assignment or 13, I don't remember. But you dropped the 2 lowest scores. Okay, so this means you can skip 2 homework, but in order to prepare you for the exam, you better do them all, right? And also as the quizzes, we have 7 quizzes. You drop the 2 lowest scores. So, but also in order to prepare for the exam, I suggest you to do all the quizzes. And exams, you can use the final exam to replace the lowest chapter exams. Okay, so let's continue. So last time we talked about session 9.3 and 9.4, the double angle identities, right? And I show you how we use the sum or difference formula to get the double angle formula. You kind of just let A and B the same, so A plus B becomes 2A. Then you get the double angle formula. And then last time we did one example, right? So this example, you were given like sine theta, and you know the cosine theta is negative, and then you want to find all the sine 2 theta, cosine 2 theta, tangent 2 theta. The idea is, given the sine theta, you can draw the point on the xy plane, express this in terms of xyr, and then you can find the remaining 5 trig functions. Do you still remember that? So we talk about this in chapter 7. And after you get sine and cosine, then you can plug in the formula of the double angle formula and get the sine 2 theta, cosine 2 theta, and tangent 2 theta. So example 2 is a similar problem. So then we're not going to go over example 2 because it's a similar problem. But how about we briefly talk about the idea. So example 2, you're also given a trig function, right? Then based on this information, you can draw the points in the 4th quadrant and you express that.
We went over this on Monday.
Oh, we went over this already? Okay, good. Thank you. So then number 3, okay? Number 3, I also want to talk about briefly the idea. So you want to derive a formula of sine 3x. So we have sine 3x is like sine 2x plus x. And now you can use the sum formula, right? The sum formula, you have sine a plus b is sine a cosine b plus cosine a sine b. And you let a be 2x and b be x. That's why you get sine 2x cosine x plus sine cosine 2x and sine x. Is that okay, everybody? We plug in the formula. And then, what is sine 2x? We know sine 2x is, see, you use the double angle formula. Sine 2x is 2 sine x cosine x, right? So we plug this in. And then, how about cosine 2x? We have 3 equivalent forms. You can use any one of them. So you can take the 2 cosine squared minus 1. So then you distribute and combine the like terms. So this is what you get. So you can express sine 3x in terms of sine x and cosine x. Is that okay, everybody? This is the idea. You can generalize this idea to like higher angles. If I ask you sine 4x, you can express this as sine 3x plus x, or you can express this as sine 2x plus 2x. And then you can use the sum formula to break it down. Is that okay, everybody? The idea of it? By the way, if you miss some class, please watch the recording. You know, our last month, we're gonna be very busy. And make sure you understand every problem on the note, your homework, the quiz, and the practice exams. And I have a lot of office hours. Feel free to come to ask me if you have any questions. Okay, good. So next one, the power reducing formula, or the half angle formula. So we have the double angle formula. Okay, so that is the double angle formula. And now focus on this one. So let me get a pen here. Okay, so let's look at this one. Do you see the right hand side? I have cosine squared, and the left hand side I have cosine 2a. So this formula is the separate formula sheet, the chapter 9 formula sheets I just give you. So in the chapter 9, you're gonna be provided this formula sheet. Okay, so look at that formula and then solve for cosine square. Well, what do? You add 1 on both sides. So you add 1 on both sides. And then you divide it by 2 on both sides. You can then express the cosine square A is 1/2 cosine 2a plus 1/2. Is that okay, everybody? How we derive the cosine square? Cosine square is 1/2 plus 1/2 cosine 2x. How do we derive the sine square? You look at this formula. Okay, let me put it here. We want to solve for the sine square. Okay, and how do we solve for the sine square? Subtract 1. So cosine 2a subtract 1 is the right hand side. You subtract 1. 1 is gone. We have negative 2 sine square. Now both sides divided by negative 2. We get the sine square is negative 1 over 2 cosine 2a. And then negative 1 over negative 2 become positive 1/2. Is that okay, everybody? So based on the double angle formula, we can get the power reducing formula. The power reducing formula, we reduce the power, but we double the angle. So is that clear, everybody, how we get those two formulas? So yes, double angle formula and power reducing formula has different use. And okay. Attendance. Okay, let's see. Thank you. By the way, if you come in late or if you miss some class, please watch the recording. If you have questions, feel free to come to ask me. Okay, so yes. And here we know tangent square is sine square over cosine square. That's why you use this over that, and you get this. Okay, so this is how we derive the power reducing formula. And now this is equivalent to the half angle formula. Why? If you let x, so if you let x be theta over 2, and then plug in on the left hand side, you get sine square theta over 2. Because we let x be theta over 2. And then the right hand side, we get 1/2 minus 1/2 cosine 2 times theta over 2. Do you see the 2 cancel? We get just cosine theta. Do you all see that? Everybody? Mm-hmm. And this is, okay, we have the 2 as the common denominator. Then the numerator is 1 minus cosine theta. Therefore, you take the square root on both sides, you get plus or minus. So you get plus or minus 1 minus cosine theta over 2. So from the power reducing formula, you let x be theta over 2, and then take square root on both sides. You get the half angle formula. Is that okay, everybody? This is how we derive the formula. Similarly, you get the cosine theta over 2. Just let x be theta over 2, and take the square root on both sides. And similarly with the tangent. Okay, so all this formula will be provided. Now I just show you why we derive those formula. So now how do we use those formula to solve examples? This is more important. Okay. Number 4, we write the sine to the power 4 as a sum of the first powers of the cosine of multiple angles. This one, I also want to briefly talk about the idea, because your exam problem won't be like that. So I just want to briefly talk about the idea. So sine to the 4th is sine square square. Yes, everybody? And then sine square is 1/2 minus 1/2 cosine 2x. Yes? Right, everybody? Look at me. Don't look at your phone. Yes, I hope you, because we're gonna speed up, okay? I hope you understand every problem. So focus in class, don't look at your phone. And okay, here we expect, therefore 1/2 square is 1/4, and then minus, remember a, thank you, a minus b squared is a squared minus 2ab plus b squared, right, everybody? So therefore, this 2 cancel. We have 1/4 minus 1/2 cosine 2x plus 1/4 cosine 2x squared. We don't want to see squared. We want to see all power, first power. Therefore, the cosine square becomes 1/2 plus 1/2 cosine double the angle. Because your angle was 2x, when you double the angle, it becomes 4x. Is that okay, everybody? When you double the angle, it becomes 4x. And then you can multiply it, and therefore you combine the like terms, you get an expression of only first powers of cosine, but multiple angle. Is that okay, everybody? So you can take the notes after class. Okay? So yeah, let's do it. Number 5. Okay. Yeah, like I said, because we're behind schedule, we cannot cover every problem in the worksheets. So some problems I briefly talk about the idea, okay, and then for some of the problems that might be in your exam, we go over them step by step. Okay, number 5, use a half angle formula to find the exact value. You may have you may need the quotient, reciprocal, or even odds identity as well. Okay, something. All right, so look at this one. 105 degree. This is not let's see. Is this a common angle? Yes, 60 plus 45. Okay, so this is sine 60 degree plus 45 degree. So this is one way. You can use the sum of angle formula. Yes, that's one way. Everybody understand what I'm talking? You can use, so one way is to use this sine a plus b, and you plug in this formula. Is that okay? Uh-huh. That's one method. But now, because the problem say use the half angle formula, so let's use a different way. Half angle formula, which is here. Okay, so 105 degree is, so let's say this is the theta over 2. Okay, let's compare. If this is theta over 2, what is theta? We need to double it, right? So theta is 2 times 105 degree, which is 210 degree. Okay, now we use the formula. Okay, the half angle formula, because it's a sine, we use the sine. So therefore, the sine 105 degree is plus or minus square root of 1 minus cosine. Theta is 210, and then over 2. Is that okay, everybody? So we use the half angle formula. We get this is the half angle, theta over 2 in 105. So theta is both sides multiplied by 2, which is 210. But how do we know this is plus or minus? Well, then you need to draw the picture. You know, this is 0 degree, 90 degree, and 180 degree. 105 is between 90 and 180. Yes, everybody? Mm-hmm. So the point is right here. Okay, do you see the x is positive or negative? Negative. The y is positive or negative? Positive. We're in quadrant 2. So sine 105 in terms of x, y are what over what?
Y over R.
Exactly, y over r. But y is positive and r is always positive. Therefore, you get the sine 105 degree is positive. Is that okay, everybody? Yes. So that's why we pick the positive. And next. So we have positive 1 minus. Now, what is cosine? 210 degree. Okay, this one, we need the reference angle. Okay, so where is 210 degree? Let's draw another picture. Third quadrant. This is 180. This is 270. So the 210 degree is right here in quadrant 3. So far, so good, everybody? Yes. And reference angle. Quadrant 3. Reference angle is the angle made with the terminal side and the x-axis. Can you see what is the reference angle? 210 minus 180 degrees. Yes. Are you okay with the reference angle? Mm-hmm. You get the t prime is the t minus the 180 degree, which is 30 degree. Yes, everybody? So we know cosine 210 degree is plus or minus cosine of the reference angle. But plus or minus depends on the quadrants. In quadrant 3, what is cosine in terms of x, y, r? X over r. Look at your x. Is it positive or negative? Negative. And your r is positive. So the whole thing is negative. Right, everybody? The whole thing is negative. Therefore, it's negative cosine 30 degrees. Now you know what is cosine 30 degrees? Root 3 over 2. Yes, root 3 over 2. Good. So now we have cosine 210 is negative root 3 over 2. And then all over 2. That is 1 plus root 3 over 2 and all over 2. If you see fraction in a fraction, you simplify. The common denominator up there is 2. So you multiply by 2 and divide it by 2. You get 2 plus square root of 3. And then all over 2. Okay, so what is that? Do you remember A over B over C over D is A over B times D over C? So this 2 is really like the C. So it's in the denominator. So you're like 2 times 2. Okay, everybody? So far, so good, right? So this is the A. This is the B. The C is 2. The D is like 1. So therefore, this is A over B, and then the C is downstairs. Now, square root 2 plus square root of 3. What is square root of 2 squared?
Root of 2 squared.
Yes. So 2 times 2 is 4. Square root 2. Square root 4 is 2. Yes. So this is our answer. So this problem, there are 2 methods. One method is use the sum angle formula, which I think is easier. Do you agree? Mm-hmm. Yes? You use this formula and you get what is sine A plus B? Okay, your formula sheet. You want to carry your formula sheet all the time in this practice. You get what? Sine A cosine B plus cosine A sine B. So you get what? Sine 60 degree, cosine 45 degree, plus cosine 60 degree times sine 45 degree. And you know all those angles values, right? And then, so you can, yeah, this method is easier. But the problem, because it said we have to use the half angle formula, then you have to use the half angle formula. And like here, because you have to figure out the sine, you draw the picture of this angle, and then cosine 210. You also need to figure out the sine and the value, so you also draw the point on the xy plane. So you can see this problem requires the knowledge we learned in chapter 7. Any questions so far, everybody? No? Okay, so yes, do more practice. Okay, 6. Suppose beta over 2 is an angle in quadrant 2, and that cosine beta is 1519 over 1681. Compute the exact value of this. So when you see exact value, can you use calculator? No. So you're supposed to show all your work of these. Is that clear, everybody? Mm-hmm. So like here, okay, beta over 2. And we're looking for cosine beta over 2. Which formula do we use? The cosine, right? Everybody? The cosine beta over 2 is plus or minus square root of 1 plus cosine beta over 2. Okay, so write this down. This is plus or minus square root of 1 plus cosine beta over 2. Right, everybody? And plus or minus, we need to draw a picture. Beta over 2 is in quadrant 2. So like here, right? And we have x, y, r. Okay, what is cosine in terms of x, y, r? X over r. This is the beta over 2 is in quadrant 2. Okay, this is beta over 2. X over r. Your x is positive or negative? Negative. Your r is positive or negative? Positive. So the whole thing is negative. That's why we pick the negative. Okay, everybody? So good. Now we plug in cosine beta. Beta is what? Cosine beta is negative 1519 over 1681. And then all over 2. Yeah, it's an ugly number. It might happen. Okay? Don't use your calculator. I mean, don't you can use your calculator when you get the fraction, but when you see the square root, you cannot like put in square root because you get a bunch of decimals, right? So but the fraction part you can use your calculator. So you know that here over 2, and then here the denominator 1681, and then here is 1681 minus 1519. Is that okay when we take the common denominator? The 1 you multiply by the same thing on top and bottom. And let's see, what is that? 1681 minus 1519 is 162 over 1681, and then over 2. And now we can then simplify. 1681. Bless you. Where do we put the 2? Upstairs or downstairs? Downstairs. So this part is similar to the previous problem, right? The 2 is like the C. Therefore, we put the C in the denominator. And can you cancel 2 and 162? That's 81, right, everybody? So we cancel it. We get 81 over 1681. This is the answer. So far, so good, everybody? Okay, so save that. Let's continue. Okay, so here we want to find the secant u over 2 if the cotangent u is negative 0.337 and u is in quadrant 4. By the way, in the last problem, we know the beta over 2 is in quadrant 2, but we don't know what the beta is, right? And then, but the next problem, we are not given information about the u over 2. We don't know which quadrant it is in. But we know the u is in quadrant 4. You see the difference between the two examples? Yes, everybody?
Sure.
Okay, so let's see here. We want to find the secant. Okay, but look at our formula. Our formula, we only have sine, cosine, tangent. So in order to find secant is related to cosine. So we need to find the cosine first, right, everybody? So in order to find secant, we need the cosine, u over 2, okay? And look at the formula of the cosine u over 2. Do you see this formula? We need to know the cosine u, right? So in order to find that, we need the cosine u. But we are given cotangent u. And bless you. Okay, so we're given cotangent u, and we want to find cosine u. After we find cosine u, we can use the half angle formula to find cosine u over 2. Then we can find the secant u over 2. Everybody okay with our steps? Okay, so bless you. Okay, given cotangent u, how do we find cosine u? And now you know u is in quadrant 4. So step 1. Okay, so step 1 here. Quadrant 4, like here. So we know that's u. In quadrant 4, we have the x, y, and r. Cotangent u. What is cotangent u in terms of x, y, r? X over y. Yes, x over y. That's you.
I'm allergic to this problem.
Yeah, this problem is hard because you see how many steps you need to do. So, okay, x is positive or negative? Positive. Y is positive or negative? Negative, yeah, because it's down, it's below the x-axis. So, and we know this is negative 0.337. And how do you rewrite that? You can put the 3.337 over 1. And because the y is negative, you can put the minus in front of the y. Is that okay, everybody? Yeah. If you have a fraction like 4 over 5, then you get 4 over 5. But if you get a decimal, then you just put this guy over 1. Okay. So by comparison, we can let x be 0.337, and we let y be negative 1. Okay. Do you see this is like what we've been doing? You draw the points on the xy plane, and you figure out the x and y. Oh, here we're looking for r. What is r? X squared minus y squared or plus y squared? Yes. And the r is always positive. We get square root of 0.337 squared plus y is negative 1 squared. Okay? Yeah, so if you like get decimal is not like a good number here, then I won't require you to like give me exact answer. Okay, so you plug in your calculator. Give me how about 5 decimal places?
1.05526.
1.005526, like that. Yes. Okay. Thank you. Oh, only 10. Okay. Thank you. All right. So this is the R. Then now cosine U. What is cosine in terms of x, y, r? X over r. So we get 1.05526 over, sorry, I have wrong. My x should be 0.337 and the r is 1.05526. And what do you get? Also give me 5 decimal places. 31925. Oh, 35. Thank you. Good. This is cosine U. Yes.
I got a different.
Oh, you get a different answer?
I get 0.2170.
Let's see. Oh, because you missed a 0 here. 1.055.
Oh,
Yeah.
Okay.
Okay.
What am I doing?
So this is cosine U. Now step 2. Knowing the cosine U, what is the cosine U over 2? All right, here. Because U is in quadrant 4, what does that mean? Quadrant 4 is what? 270 degree and what? 360 degree. Do you agree, everybody? Quadrant 4. How about U over 2? So when you divide it by 2, what is 270 over 2? 135. How about 360 over 2? 180. Oh, look at this. So this is 90, this is 180, and 135 is right there, and you know now the angle is in this range. But do you see it's in quadrant 2? So U over 2 is in quadrant 2. So even though you only have the information about U, you know it's in quadrant 4. But you can divide it by 2 on the bands and figure out that U over 2 is actually in quadrant 2. Is that okay, everybody? All right. Now, let's see. So the cosine U over 2 is, look at your formula. Tell me, what is cosine U over 2?
Minus root 1 plus cosine U over 2.
Yes. Is that okay, everybody? Ooh. We're using this formula.
I'll just exchange the theta for the U.
Exactly. Just change the theta to the U. And now, plus or minus. Because this is in quadrant 2. What is cosine again in terms of x, y, u? X over r. Right. X over r. Quadrant 2. The x is negative. The r is positive. The whole thing is negative. Good.
Why is it negative? Is it because the x?
Oh, because the x is negative.
Okay.
So negative over positive is negative.
Positive over negative.
Still negative. Yes.
So if there's a negative in thing, it's always negative.
If you have one negative multiply or divide together, it's negative.
Yeah.
But if you have two negative multiply or divide together, it becomes positive.
Two
So it's
negatives make positive.
Yeah, to negatively positive. Right. Good. So this is minus square root 1 plus, what's cosine u? Yeah, very good. And then over 2. Okay, could you give me 5 decimal places? Sorry, 8, 1, 2, 2. How about one more digit? 0. Oh, okay. Right, everybody? So far, so good. This problem, yeah, I would say might be the hardest because it requires longer path. Okay, finally, I got my cosine. Now I can find the secant. What is secant u over 2? Exactly. So 1 over negative 0.81220. Put this in your calculator. By the way, in your calculator, do you see the answer, Vincent? So I hope in your calculation, like here, don't divide by just this number, there's 5 decimal places. Divide it by the answer. And it's the long digits. Okay? And then here also, when you add this, don't just add this number, add the answer. Okay? So then you're in fact more accurate. Okay, what is your answer? Thank you. Negative 1.23122. Right, everybody? So we finished the problem. So in the exam, I can ask you to find any trig function of a half angle, and I can give you any trig function of the angle u. And this is how you can solve. Is that clear, everybody? Yes. Okay, good. So next part is gonna be, I would say, the easiest type, because this is the sum to product to sum identities, and the formula will be given in the exam. So you see, which is this part, and how you do is, for example, this problem. You want to rewrite the products as a sum or difference. Cosine sine. Which formula is cosine sine?
Bottom.
The bottom one. Okay? So you look at the form and decide which formula to use. After you figure out this formula, then you just plug in A and B. So what is A?
Cosine 5x.
Yeah, A is like 5x. The B is like 4x. So therefore, this equals, plug in the formula, 1/2, and then sine, right? Sine 5x plus 4x. Yes, A is 5x, B is 4x. Minus sine 5x minus 4x. Yes, good. Okay, what is 5x plus? Good. Yes, and that's it. Is it simple for this type of problem? Yeah? Yeah, this is a long calculation. You look at which formula match and then plug in. Okay, let's see. How about the first 2 rows student do number 9, and then the last row student do number 10. So you have some practice. Which formula to use? Measure number 8. Have the worksheets. Yes. Yes, we can do that. Yes. If you finish your problem, you can do the next one. And the cosine is negative, so you can do that. yes, we can do it at the same time. Six over two. All right, let's check our answers. Okay, so all right, number 9. So number 9, we have cosine, cosine. So we use the first formula, and the 8 just stays here. And then 1/2 cosine A is 19x plus B is 28x plus cosine A is 19x minus B is 28x. And then 8 over 2 is 4. You got cosine 19x plus 28x is 47x. And then plus 19x minus 28x is negative 9x. Do you remember cosine equals negative? Because it's an even function. So that is in fact cosine 9x. And number 10, 6 remains there. Sine is the second formula. So you plug in the formula and you see 33x minus 17x is 16x. 33x plus 17x is 50x. Is that okay, everybody? Mm-hmm. So again, make sure you understand every problem in the class notes, your homework, the practice exam. If there's some problem you don't understand, please come to see me in my office. You know, in class we have a class time limits, but in my office we don't have a time limit. I'm happy to explain the concept to you slower, and we can do more practice. Okay, so bye. Have a good day. Next class, pre-now session 9.5. Mm-hmm.